Welcome to the Museum at MFIT's Material Evidence, Assessing Risk in Museum Collections Virtual Symposium. My name is Tania Melendez Escalante, and I am Senior Curator of Education and Public Programs. It is my honor to introduce Anne Coppinger, who will present the talk, Material Evidence, Assessing Risk in the Collection at the Museum at MFIT. Anne Coppinger has directed the Conservation Department of the Museum at MFIT for more than 16 years. She has an MA in Museum Studies with a specialty in costume and textile conservation from MFIT. We thank the U.S. Institute of Museum and Library Services, as this project is made possible by a grant from IMLS. We hope you enjoy the show.
I will be speaking about a grant-funded project to test objects in the museum's collection for hazardous substances. In 2019, the museum received an Institute of Museums and Library Services grant under the Museums for America Collection Stewardship and Public Access Program. Most likely, these problematic substances would have been used in the manufacture of fashionable clothing and accessories. The increasing concern of potential toxicity in historic fashion and textiles was a strong incentive for the museum to strengthen its understanding of potential hazards within its own collection. The museum at the Fashion Institute of Technology is a mid-sized museum within the urban campus of FIT. The college is part of the State University System of New York and is located in the trendy Chelsea neighborhood of New York. The college's strategic plan refers to the museum as the jewel in the crown of the college. The museum, originally called the Design Laboratory, was founded in 1969 to support the educational programs of the college. In 1993, the Board of Trustees of FIT changed the institution's name to the Museum at FIT. Dr. Valerie Steele was named director of the museum in 2003, and the museum was awarded accreditation by the American Alliance of Museums in the summer of 2012. The museum is dedicated solely to the art and research of high fashion objects, as demonstrated by the quality and breadth of its collections and roster of groundbreaking exhibitions. One of the tenets of the museum's mission is to educate FIT students, researchers, and the general public on the unique cultural history of fashionable clothing and accessories from the 18th century to the present. In the fall of 2016, the museum's conservation department was preparing objects for exhibition in the museum's first floor fashion and textile history gallery. Force of Nature looked at the relationship between fashion and the natural world. At the same time, I was reading Allison Matthew David's 2015 publication, Fashion Victims: The Dangers of Dress, Past and Present, and began to consider what type of objects comprise the museum's collection of approximately 50,000 fashion garments and accessories. Although a good portion of the collection was made in the 20th century, there were many 19th century objects similar to those highlighted in Miss David's books. Here is a selection of collection objects that had been chosen for display in the Force of Nature exhibition. These included many elaborately decorated women's hats with taxidermy birds or intricate feathered attachments. There were already concerns about arsenic-based preservatives that may have been used in the taxidermied specimens. Also included was an 1870s ivory file wedding gown trimmed with green silk foliage that seemed suspiciously like what Miss David had described in her book's chapter on arsenical greens, a toxic pigment made from copper and arsenic trioxide. Since the museum does not have a scientific department to do testing, a sample of the green leafy trim was sent to a conservation scientist colleague at another institution, who determined that the leaf contained trace amounts of arsenic and lead. The hem of the wedding dress required a lengthy stitch stabilization. Based on what was discovered, the conservator treating the garment wore a lab coat and disposable nitrile gloves. It was also decided that the dress could only be handled with nitrile gloves and little to no steam could be used while dressing the garment. So here it was, undeniable proof that we had an issue. A search of the museum's record revealed no documentation of the use of pesticides on the collection. However, a deep dive into research revealed that the methods by which high fashion objects were manufactured and the dyes or mordants used to color objects could be an issue. Early manufacturing processes of fashion items were extensively researched. Several problematic chemical-laden procedures were identified as being used in the manufacture of consumer fashion goods. Those identified included the formulations of early synthetic pigments and dye stuff, a mercury-based carroting process used in felt hat making, and arsenical taxidermy preservation practices. This punch cartoon, dated from February of 1862, warns of the dangers of contemporary green colorants. At the time, there were very few natural sources for green dye, so the development of inorganic pigments or mineral dyes was significant. In 1775, the chemist Carl Wilhelm Scheele invented a copper arsenic pigment called Scheele's green. In 1814, Russ and Sattler developed arsenic-based Paris green in an attempt to improve upon Scheele's pigment. In the 19th century, health professionals were just beginning to understand the toxicity of arsenic compounds, but by the end of the century, both greens were made obsolete by less toxic green colorants. Here is an image of the hatter from Lewis Carroll's 1865 novel, Alice's Adventures in Wonderland. He wears a tall gentleman's hat and is referred to as Mad by the Cheshire Cat. Mercury was commonly used in the manufacture of felted animal hair hats. The term carroting was used to describe the mid-18th century process used for the quick removal of animal hair, which turned it bright orange. A solution of mercury salts diluted in nitric acid was applied to either the pelt or the fluff. The chemicals dissolved some of the keratin scales on the fur, which would make them interlock more easily in the felting process. The use of mercury caused a high rate of poisoning amongst those working in the hat industry. Mercury poisoning causes neurological damage, including slurred speech, memory loss, and tremors, which led to the phrase "mad as a hatter." The United States Public Health Services officially banned the use of mercury nitrate in 1941. Faced with these concerns, the museum applied for an IMLS grant to begin the process of a non-destructive analysis of the museum's collection. This funding enabled the museum to conduct a collection survey for the presence of hazardous materials that may have been used in the manufacture of fashion objects. The funding included the rental of a Bruker Tracer 5i X-ray fluorescent spectrometer and the services of Cheryl Podzicki, a specialist contaminated objects conservator. Ms. Podzicki had done extensive testing of objects in Chicago's Field Museum and was eager to take on the challenge of testing fashion objects. The XRF spectrometer performs non-destructive elemental analysis and will detect the presence of heavy metals in a substrate. The instrument generates a high energy beam, which is aimed at a site on the object. This will excite the object's atoms, and the resulting X-ray fluorescence is measured. Artex software analyzes the resulting data, produces a spectrum, and it compares it to a reference spectrum in order to identify metals. XRF can detect the presence of heavy metals such as chromium, arsenic, cadmium, mercury, and lead. However, XRF cannot detect the amount of those substances present. The next step was to identify a group of objects to be tested. Informed with the knowledge of early manufacturing processes, the museum's database was searched to identify potentially problematic objects using search terms such as green, feather, and fur that were cited in an object's description. The funding allowed for a total of 165 suspect objects to be selected and non-professionally photographed. The photographs enabled Cheryl to accurately map each object's test site. After a protracted COVID pause, testing was conducted in the Conservation Department lab over the course of 4 weeks, ending in November of 2021. Safety protocols were established prior to the start of testing, and the safe handling of XRF equipment and objects was discussed over lengthy phone conversations with Cheryl. The lab tables were covered with polyethylene sheeting. Lab coats and nitrile gloves were used while testing the objects. Nitrile gloves were frequently changed and disposed of in the lab's hazardous waste bin. The use of full facial covering was observed due to FIT's COVID protocols. It was determined that due to the thin nature of textile objects, individual object testing would be conducted by placing the object elevated and away from the lab table surface. The object was placed on top of an archival box so that the XRF instrument could not pick up any errant readings from the wood and cork surface of the tabletop. The box was covered with polyethylene sheeting, and the front aperture of the instrument was covered with plastic food wrap to prevent any possible cross-contamination. After the testing phase, the data gathered from the XRF analyzer was compiled for each object. The final report for each tested object included site-specific spectrum and annotated documentation that was linked in the museum's database to that object's record. The following is a selection of XRF results from the hats that were exhibited in Force of Nature. This 1939 black felt women's hat is trimmed with large brown and red bird feathers. It was determined that the bird was not an intact specimen, but a compilation of bird feathers and plastic bits. On the right is the spectrum from that object, indicating the presence of mercury and other metals. Here is another black felt women's hat from 1954 with taxidermied hummingbirds on either side of the front of the hat. Arsenic was found on the hummingbirds and mercury was present in the felt hat. This woman's all-over feathered cap is dated to 1953. The hat features both solid green and multicolored iridescent feathers. On the right is the first page of the object report with the annotated test sites and general results. Note that 3 distinct sites were tested. The XRF analyzer will give readings only for the specific sites tested. It needs to be kept in mind that with the multitude of materials that are used in fashion objects, each material should be tested. Here is the spectrum reading from site 1 of that hat, specifically the green feathers. No arsenic or mercury was detected, but lead was detected on many objects. It is speculated that this result may have come from the fact that the museum's objects were housed in an urban environment where lead pollution was present. The museum's current storage spaces now have a closed air handling system. This woman's hat from 1946 is lavishly embellished with multicolored feathers and a dramatic feather plume. A total of 5 sites were tested on this hat. The spectrum on the right in the reading is the reading taken from green feathers on the center front of the hat, which detected arsenic. Here are the results from a woman's black felt hat from 1955, which is dramatically trimmed across the front with the bird of paradise. On the left is the first page of the final report annotating the 3 specific test sites. On the right is the spectrum results for test site 2. Arsenic was found on the taxidermy bird of paradise at test site 2, and mercury was found in the felt of the hat. Here we are looking for the notorious arsenical greens, and so it seemed that this 1830s brilliant green silk satin dress was surely a candidate for testing. Arsenic was not detected, so it is surmised that this green shade may have been obtained by the use of a combination of blue and yellow organic dyes. This 2-piece women's green silk file day dress is from 1865 and is trimmed with chenille and silk fringe. A total of 7 sites were tested on the bodice, none of which presented as arsenic. It was decided that when testing 2-piece ensembles, we would test the bodices only. The skirts tended to be large and would require a lot of handling, and the bodices usually were made from the same fabric as the skirt, but were more heavily embellished with other materials that would need to be tested. Oddly enough, we were somewhat disappointed that no arsenic was found on any of the green items that were tested. Next, on to the hat tricks. Here are some findings from our collection of men's top hats. This beige beaver hat is dated circa 1850. The hat was cataloged as beige beaver with a matching grosgrain ribbon band and trim. As expected, the hat tested for the presence of mercury. These 2 top hats serve to highlight a newly discovered issue with cataloging and identification of materials. The hat on the left was described as a black beaver top hat, so a definite candidate for testing. The hat on the right was described as a black plush top hat. However, both hats tested for the presence of mercury. The test results were somewhat contradictory to the anticipated results. So it was decided that destructive material testing would be necessary to aid in explaining the XRF results. Small fiber samples were taken from the hats and examined with polarizing light microscopy. The taupe hat was identified as animal hair, and the 2 black hats were identified as silk. This anomaly gave us the opportunity to look at all 33 of the men's top hats in our collections. The hats date from 1850 to 1970. Fibers from 20 of those hats were sampled and identified. The pie chart on the left illustrates the breakdown of men's top hats in the collection. There are 19 silk plush, 8 of which were incorrectly cataloged as fur felt. There are 12 silk rib weave, 1 worsted wool, and 1 animal hair, possibly beaver or a hair mixture. The bar graph on the right details the 10 hats that were tested with XRF. Of the 8 silk plush hats that were originally cataloged as fur felt, 5 tested for the presence of arsenic and 3 did not. 1 silk rib weave hat tested for the presence of arsenic, and 1 animal hair tested for the presence of mercury. Research was done into the silk hat making process. Little information could be found about the actual fabrication of the silk hatter's plush textile, but information was found detailing the hat assembly process. It was concluded that arsenic or a related arsenical compound was used either as an ingredient in a fixative or adhesive solution during the hat manufacturing process, or used as a dye mordant for the black silk plush fabric. More testing and research needs to be done. Subsequently, all of the tested hats have been labeled and nitrile gloves are used when handling the hats. We also tested several 20th century hats, expecting to find mercury in those dated to the first third of the century. But we did not expect to find mercury in hats that dated to the second half of the century. Research indicated the use of mercury in hat making was outlawed in the US in the 1940s. It is recommended that mercury-laced hats should be sealed in order to contain mercury vapors. However, there are 1,500 or more felt hats in our collection, so bagging all of these did not seem feasible. It was decided to conduct air quality testing in the storage room to get a sense of the quantity of mercury vapor being emitted from the hat collection. In March of 2022, an environmental contractor was hired to perform indoor air quality monitoring in the museum storage room where all the hats are kept. Mercury vapors were measured and monitored with a Jerome J505 mercury analyzer, which uses atomic fluorescence spectroscopy for mercury analysis. Small amounts of mercury vapor were detected at various shelving sections in the aisles where the hats are stored, with results ranging from 0.0 to 0.00006, or 600 thousandths of a milligram per cubic meter. All mercury vapors results were well below the OSHA and NIOSH exposure limits. However, any future treatments that include the use of steam, which may serve to further release mercury vapor, will be done cautiously under a fume hood. The museum's grant-funded survey was a valuable tool in determining problematic materials in the museum's collection. It also enabled museum staff to gain a better understanding of toxicity issues in the collection and has effectively increased awareness of the need for safe handling practices and the use of personal protective equipment. The study resulted in scientifically gathered information that served to inform revised object handling protocols and storage procedures. Those objects that did test for hazardous materials may have been tagged with cautionary labels, and their records in the museum's database have been annotated. The hope is that this will ensure the safe management and accessibility of the collection to all museum staff, students, and researchers, as well as secure the future of the objects. Thank you so much for listening, and to all those who made this study possible.